So today's interesting question is rotate array. Okay, so you will be given an array, like this kind of array will be given to you, which contains some number that may be positive, that may be negative, and you will also get a k. Okay, so what you have to do here, it's written rotate the array to the right by k steps. Okay, means here the steps is written, that is given in the k. So you have to take these three numbers from the end and put it at the start. Okay, this is known as rotation. Okay, you have to rotate the number from last to first. So one more thing is also mentioned, that you have to do in place modification, means you are not going to return anything. Okay, means in that array itself you have to do your rotations and all. Okay, that is known as optimized solution, because you can use brute force and use one more array and simply traverse here and do that. Okay, that is brute force approach, which you can tell to your interviewer that by using another array we can just traverse from this to end and from start to here and store it. That is the simple brute force approach. But we are going to do the optimization approach, which will beat 100%. But before solving the question, I just need to show you that this is my channel. If you have not subscribed my channel, then please subscribe if you are preparing for your interviews, because I make the videos very short so that you can understand. And this is my playlist for all those videos. If you are preparing for your interviews, you can go through it. It contains all the videos. If you are specifically want arrays videos, then you can go through this. This is recursion playlist, this is string playlist, and other playlists are also there. You can go and watch it. Okay, so let me start the video by explaining you what you have to do. Assume this is the array what is given to us, and this is the k. What we have to do means we have to take these three numbers from here and put it at the last. Okay, that is what we have to do. So here, before solving this question, assume this k is given 0 to you. Maybe this k can be given 0. Okay, that can be the answer. If that is the case, you have to return the array completely. We have an array of 6 length, but if this k is 6, so are you going to rotate the complete array again? And if you see that, again if you rotate this one 6 times, the same array will be returned. So there is no meaning of like rotation. Okay, so you should not do this kind of solutions. So if you see it properly, what we can do for optimizing our answer is, if it is 7 times, think what will be the answer. That means 6 time rotation means same array. One more is left, that means 6 will come to the first. So if we do the modulo operation, whatever the k is there, k modulo nums of length, then we can simply get 1. Okay, means number of rotation what we have to do. So if you get 7 or any number, even if it is less than the array, just do modulo of it with whom? Nums dot length. This will give you the length of it, and you have to simply do modulo operation with the k. Whatever the k is given, just do modulo operation with the length. Okay, then this will return how many rotation you have to do. Okay, so we got from here what? We will get one rotation we have to do, or assume this is not 7 as we have initially like 3 at the starting. So if k is 9, k moduli nums dot length is what? Simply it will return 3 to you. Number of rotation is 3, so we have to take these 3 numbers from here and put it at the start. So let me create an array and store all the elements. Okay, whatever the k element present at the end of this array, I'm storing it. Means I will start a for loop from here, means for loop from nums dot length minus k. So the index will be this, and I will store it. Okay, I'll prepare a k length of the array and I will store all those elements here. So as we have taken the backup of the last k elements here, so what we can do, we can simply use these spaces or use these indexes what are available. So if I want to remove this also, like if I remove this from here, okay, then I can store these 3 to here. So for storing this 3 here, what we can do? We can apply some sort of formula and we have to run a loop from end towards starting, but you have to run a loop up to k, because at last you also have to store this 4 5 6 here. Okay, so you have to move up to this, means it should be greater than equals to 0 in this direction. From end towards the start we will be running the loop, and what the formula we will be applying, the formula is this one, that is whatever the index we are currently standing minus k. So here the length of this complete is what? 6. So 6 minus 1 is what? 5. So 5 will be the index for this. So 5 minus 3, as 3 is the k, 5 minus 3 is what? 5 minus 3 is 2. So we'll just take the 2 index value, put it here. Then I value decreases, so we can take this value, put it here. Okay, then we'll move to this index, then we'll take this value, because I value again will be minus minus, so we can put this here. Then simply what we will do, we'll not use this formula anymore. Then for storing this k elements, what I'll do, I'll simply go here, take this one, store it here, then increment my index, then again I will go here, store this 5 here, and again increment my index. Okay, then at last I'll take this 6 and store here, and I have successfully completed my rotation. One more thing that I want to mention, that we haven't used any more bigger spaces, because this k elements we have to store it anyhow. Okay, because we have to use these spaces, so no extra space. You can see this is a constant space because k is constant. Okay, and we have used big of n time traversal. Okay, and one time traversal for this k, you can assume. So overall time complexity is big of n only. So let me solve it and show it to you. First of all, I will store the length of this nums dot length. Okay. And whatever the k is, I can simply write k equals to k moduli length. Okay. So this step, whatever we have done here, I'm doing it. And again, if after doing modulo, we get k equals to 0, that means we don't have to do any iteration. We can simply return the nums. Because if that is 6, I have given one example that if that is 6 and length is 6, so at that time we don't have to do any iteration, right? So after that, what we'll do, we will be simply extracting those values, okay, those values, and storing it here, like 4 5 6 we have to extract and store it. So I can just name it as arr, and this is nums dot slice. So slice is a method present in the JavaScript. If we pass the starting index and we does not pass the ending index, so it assumes the ending is the end. And here I passed length minus k so that it will only extract the last k elements. Okay. So then what I have to do? I will simply run a for loop for let I equals to length minus 1. Okay. So that we will traverse from last and we'll go up to where? K. And I will simply do I minus minus, and we will simply apply that formula, whatever is written here, that will be working. Okay. Nums of I equals to nums of I minus k. After storing this, all the elements means we have stored 1, 2, 3 as of now. Now we again have to store k elements. So that k elements are present here in this array. So we can simply write that for let I equals to 0, I less than k, and simply do I plus plus. So here we can simply write nums of I equals to array of I, because same number of elements present in the I, same number of indexes we will be using in nums to store it. And at last we don't have to return anything that is mentioned in the question, so we'll be not returning anything. You can see 2 test cases passed. So let me submit my answer. You can see our answer successfully passes all those test cases and it beats 86.36%. So if you like my approach, then please subscribe the channel, share these videos with your friends and who are preparing for interviews. You can share with them. That's all for today, guys. Thank you for watching.